In the last video, we were looking at how to insert a step file on Onshape and also to Autodesk Fusion. In this other video, we are going to take a look how the constraints or mates work in these two softwares. Okay, so we are going to start on this subassembly. So this is the subassembly, and what I'm going to do is to right click on the assembly here at the model tree and click on switch to. Okay, so we have the assembly with 3 parts, and as you can see, it has a marker here on the model tree that shows that this part is actually totally free, so I can drag it all over the place. They are completely floating without restrictions. Okay, so I'm undo these operations to get them back in the correct position. I'm going to select this first part and I will right click and now click on fix. So with this, you can see that this symbol has changed, and now what I have is a part that I cannot drag. Okay, I will drag these other two ones, and now we need to insert or add restrictions. So in this case, they are orientated on the way that I want them to be. So it will be as simple as use the Fastened Mate. This is a type of mate that, let's say, restrict all the movement in just one click. So what we are going to see in here is that as long as we move the mouse over the 3D model, there are going to appear something called mate connector. So the way how this works is that it recognizes the face and it adds automatically potential points from where you can grab and constrain your part. So as you can see, I have many points in here that probably not very useful in this case, as well as in here. But what I'm going to do is to select the bottom inside this part. I have just done a click, so you can see there is an icon, a small icon there. That one is the mate connector, and I'm going to select the second reference that in this case will be this face. Okay, so with that we have the part totally fixed in position there. We can use this option of here for reoriented the secondary axis, so you can flip the thing. In our case, that's the correct position that we want. Okay, I will click in here. And now we are going to do the same thing, but in this one. So as this has been drawn symmetrically, so I can take that point on this part and this other point in this other. So those are going to work. Okay, perfect. Okay, so now let's, okay, well, please note that we don't have anymore the symbol of a triad right next to the name on the model tree. That's because it is completely fixed, okay? So no movement expected from this assembly. Now let's jump into the main assembly, and the subassembly itself is floating because we just add mates to the internals, right? Okay, so I will right click and leave it there. Let's jump into Autodesk Fusion to make exactly the same work. So something to notice is that when you click on something in Fusion 360, you need to right click and then click find in browser in order to find. Fusion is going to highlight where is that selection on the model tree. Okay, so we found it. In Onshape, it is going to be a little bit different. If you pick one face, it is going to highlight what we're selecting. Let me try to pick something that is not graphically in here. Let's say this assembly, for example. So I will move my model tree all the way up, and I will now select this component, and the thing scroll down automatically. So it is easier to find the subassembly or the part that I'm selecting on the model tree. Let's say 2 clicks less than in Fusion 360. Okay, so let's get back to Fusion. All right, so we need to modify this right in here. So we could click in this circle. It is going to activate this specific subassembly. Let me undo this, and we can also right click on the thing. Let me check if there is an option for open separately. Doesn't seem like. Okay, so we will have to deal with working here. So a couple of things that we could do is to isolate the assembly. I think that's a acceptable option. And now I'm going to activate. All right. Okay, cool. So I will collapse this thing, and yeah, very interesting. On Onshape, this part was the first part of the model tree, and this one is inverted. Okay, so for this one, I'm pretty sure, yeah, I'm pretty sure I'm working on the assembly, on the subassembly, because I have this point on the circle. Now I'm going to right click and click on the option is ground, I believe. There you go. It's the spin. Yeah, there you go. Sorry. Okay, so this one in this environment, or in this internally in this subassembly, is totally fixed in place. I'm not sure about the rigging relation. Yeah, I did this thing so long time ago. I'm pretty sure I was not using good practices on my 3D modeling. Okay, so I'm going to drag these other two components, and I'm going to show you the command called joint. So it works exactly the same as in Onshape. So what we look is for parts geometries that can give us points from where we are going to pick a certain orientation, position, and so on. So the difference in between Onshape and Fusion is that this component, or that, sorry, this tool includes the options for add degrees of freedom to your mate. In Onshape, you have separate things, separate tools for call that option for add different degrees. Okay, so in here, and we have a more graphical way how to rotate the stuff. On Onshape, you go clicking the thing for changing the orientation, but it is always in 90 degrees. Maybe someone on the comments can leave me to tell me how I can add precise rotation, if that's possible. I believe with the offset option, but I'm not sure. So in Fusion 360 or Fusion, sorry, we can just drag to the precise point we want, or we can type the thing right away. Okay, so let's leave it on 90 because that's what works in this case. Yep, or not. 1 second. Yeah, it works in 90. And I can also add the distances, right? Okay, so I can control all those parameters in one single command. Okay, so I will hit the command again. Let me pick the center that we pick in the other one before. There you go. And I will pick this other one. Okay, so right now we're going 1 to 1. Let's say we need to hide these guys in here. So the way to do it is by finding them on the well, there are many ways, but this is one of them. So you can go inside this folder on your subassembly and click on the eye. This is going to contain the different joints that you have in this subassembly. Okay, now I'm ready. I want to go to the main assembly, so I just go and click in this top level circle. It's going to activate the thing. We are not anymore in the subassembly editing, so I'm going to right click and click on unisolate, and I have the thing back. Okay, and as well as on Onshape, I'm going to drag this thing, say it's not moving. Huh, don't forget to subscribe. Okay, so yeah, but for a reason it is fixed. I don't remember if I have gave a constraint or something like that. No, I don't think so. It it should be floating from what I think. It's pretty interesting. Okay, and how about this one? This one is moving. I was expecting this thing to move. Okay, it's not moving. We will find out in a bit. Okay, so that's similarities on how to constrain something, fully constrain something, right? So this subassembly has internal components and the components are not going to move at all. Okay, so the other practice that happens in these two pieces of software is to group everything, right? So if I want to give a potential move to this component because it is going to be a spring loaded. By the way, the spring is missing in this model. Well, in Fusion you can see it. There is the model of the spring. So if we want to add that movement, we will have to work around this thing a little bit. So that's something that I'm going to prepare in a bit, and then we come back to the function of making a sliding movement in here. All right, after all this work around with these things, now we got something similar to compare. Okay, so the software has different tweaks in between them to reach to this point. So the group making on Fusion 360, it works even in between parts that are inside the subassembly. So let me show you this, for example, this part. Find in browser, there you go. Okay, so if I click in here, you can see these ones are part of the same subassembly, which is okay. And I was also able to make a group relation with these two guys that are outside this subassembly for a reason. Let me show you. Those are at the main top level assembly. So that's one of the differences. In Onshape, I was not able to do that. So because when I was creating the group, the thing used to highlight the entire subassemblies. It doesn't let you to make groups on the top level assembly with parts that are inside the subassembly. That also kind of makes sense, you know. I won't complain. So from our last video, we did a rigid group with this section of here, with this subassembly. Let me show you where where it is. There we go. Okay, well, it's actually the top in this one. So this has been grouped together and fixed in place. So the fixed in place applies to the subassembly, which is something that is totally fine. In Onshape, you cannot fix subassemblies. You need to fix parts. So for example, in this one, so as you can see, here is the subassembly. The subassembly appears as fixed, but in reality, what I had to do is to fix a part of the subassembly inside the top level assembly, so it is not going to move. Okay. Um, Let me check. There is other difference in here that was important to highlight. Okay, yeah, sure. So as I was not able to make groups from parts that are inside the subassembly, I had to create a copy of this assembly and have them separately, so they can have separate movement in between them. Why this thing is moving? I forgot to give the group command there. Okay, now it should be moved. Okay, so as you can see, there are 4 subassemblies that are movable in between them right now. I didn't spend the time to create mates internally on them, as I shown at the beginning of the video for this subassembly of the arm. Right now, they are just working as group, so we don't, let's say, waste time on that thing if the intention is not to even move them in between them. Okay, so there are a couple of things that I would like to ground, like these 2 pins, and well, the thing at the back is already made. Okay, so let's say they're going to be fixed. Now they're fixed. In this other one, we need to also do something similar. That will be to pin, I would say. Okay, so let me, if I ground this thing or pin, it is still movable. So what I need to do is to create another rigid group. No option. Capture position, it's okay. Okay, and now for this other one as well. Rigid group, yes. Oh, by the way, there is something important. If you're following this tutorial and doing it on your computer, remember this 3D model is available on GrabCAD. I leave the link below. This is a model that I did long time ago, so it is done in Inventor. I'm going to share also the step file so it can be easier for you guys if you don't have how to translate the thing into step for use it inside Onshape or inside Fusion 360. Okay, so at the beginning I was grounding this component, but the problem is that the component is now ground also for the main assembly. So this section of here, it was not movable, so I had to enter inside the subassembly and remove the pin condition. So now it can move everything together. It was tidying up the entire rest of the group just because of that condition. Okay, now let's get into the assembly itself. I'm almost sure that this thing is not going to perfectly match, but we will try to make it work. Let's start with Onshape. So now we're going to select the Revolute command, and I'm not going to fight against the thing, you know. So what I'm going to do is to keep it simple. Now we need to select the marker here at the center, the connector mate, the mate connector, and I'm going to assemble it against the point where I need to. So it will be this one in here. If I click in there, the thing is in position now. There is an offset that I will prefer. Oh, hold on. Wrong face. Let me pick again. It should be the external one. Come on. That one. Nope, not working. I will have to cancel. Sorry. Let's do it again. Don't forget to subscribe. Okay, so the one at the center, you can do it. Oh well, you can pick the edge. It's going to be similar. Okay, now let's go inside this thing and use this one of here. Oh, no, no, it's that one. Yeah, that one. Okay, sure. So we have, okay, well, no, seems like there is not much space. Okay, cool. So now I'm going to drag this one, and this one is having the correct movement for what we want. Okay, so Revolute command. Let's go inside Fusion 360. Okay, so we're going to use as well the joint command because we are comparing one to one. Okay, so a difference in between that I find right now is that on Fusion you can put your cursor over a face, and when you click, or sorry, you hold Control key on your keyboard, you can move along the different points for connecting of the joint without having them changing because of other faces that are on the way. So I will pick this one in here. Now let's go to find out where I need to locate it. Oh, too much soon, sorry. Oh, there you go. I just made it there. I will change the motion and leave it as a revolute as well. So now, as you can see, it is making a nice preview. If for a reason you don't want the preview, there should be a way how to disable the preview. At least you can replay it again. Okay, let's click OK. Okay, so now it is made in position, and I can drag it and I have the same movement. Perfect. This guy in here, I will right click and just click on show hide, so it is not going to be there. That's other way to hide the mates. Okay, perfect. So now let's do exactly the same thing, but with the other two arms. Okay, so we got our arms pivoting as expected. Now let's get the section of the piston get on the slide condition in here. The question is how we're going to do it. On both softwares, there should be a way, but we will have to find out. Now, this time we're going to start with Fusion. Okay, so the most obvious thing I would say is that to take a reference from the bottom to the bottom of the piston itself. So I will keep it simple. I will go in here, pick this edge, and I will pick this other end. Okay, so it is using the last option that I used, but I will need it to be a slider. Okay, perfect. There are some limits, so I will set them later. Maybe. Yeah, okay, let's click OK. Perfect. So the thing is pivoting and moving along the thing. Okay, so that's easy. That was easy, I would say. Okay, now let's go with Onshape. Okay, so in Onshape, we're going to use the slider mate. We're going to click in here and also going to click in here. I can rotate 90 degrees, which is perfect and convenient for this assembly. And I will just click accept and close the comment. Okay, so let me drag. Oh, there is something happening in here. It is not pivoting. Oh yeah, no, it is. Sorry. But it cannot replicate both movement at the same time. Is that what I interpreting from here? Come on. Okay. Let's see in Fusion 360. Fusion, you can drag and also make the slider movement and also the pivoting thing at the same time. So on Onshape is that it doesn't exist. It's just the motion cannot be replicated in both at the same time. it's it's okay. I mean, could be worse. Okay, so now let's get into the point where these two are going to be together. The arms and the pivoting, the piston, let's say, or the actuator. So I will say on as a guess, what I need to do is to a cylindrical mate. Allow translation and rotation about the z-axis. That sounds like what I need to do. Okay, so let's pick this, and now let's pick, well, I will pick this one, I guess. Okay, that looks like okay. Let me rotate like this, click accept. Oh, there you go. Perfect. So the result is what I want, to be honest. Oh, now I can replicate the movement in all the directions. Perfect. That's perfect. I like it. Okay, so let's repeat the same thing. Cylindrical mate. I will pick this one and this other one. It is going to like force the preview, but it's not exactly what is going to happen at the end. Okay, great. So we have the thing in here moving as expected. Perfect. So let's now try in Fusion. Let's see. So in Fusion, I will say um, with potentially with a regular joint, it will be. That's a good question. Oh, there you go. It will be cylindrical. Cylindrical sounds like rotates and slides a component on a single axis. Same thing. Okay. So let's go on positions. Let's pick this one, and as well, let's pick this other one. So it can be exactly the same thing that we did on Onshape. Okay, the preview looks like strong with what we want. But yeah, there you go. At the end, it is exactly the same. Perfect. Perfect. Same things. Okay. So um, let's see. Let's repeat the thing. I believe it doesn't matter which point we select at the end. The thing is going to adjust. So yeah. Oh, okay. There you go. Nice preview. Click OK. Okay. Now everything is being working as expected. Woo! Yeah, we got some luck. Okay, so at least let's get the limits set up, and we are done with this tutorial. So I'm going to measure what we have at this point. Oh, there is a preview. It says 0.712 inches. Yeah, that's correct. Let's say that it can be 0.7 inches. I'm a millimetric guy, to be honest, but yeah, this thing for a reason came as a inches template, I believe. Okay, so I will right-click edit joint, and I will set my limits right in here. So the maximum is clearly 0.7 inches, and the minimum, let me see how it is doing the preview. Okay, cool. So let's say 5.5. No, it looks like it can be 0.4. Well, no, potentially no. Let's leave it as 0.5. I'm not sure about the spring, what is going to happen with the spring, but it's okay. Now I'm going to drag. Oh yeah, it is having the limits. Perfect. Okay, so I will like to hide all those. Jesus, this 3D mouse. Okay, all these indicators for the relations. So I will hide them here at the top level folder because those live in there. I wonder why this one has not been moved. Let's find in browser. Okay. Ah, yeah, it is inside the subassembly. That makes total sense. So I have just add, let's check out this thing. Ah, no, but I cannot open separately. It's exactly the same. Let's leave it like that. Don't forget to subscribe. So let's get back in here. So we want to add the mate relation. So sorry, the limits for the mate. So is the last thing that we added? No, is the slider right in here. Okay, so I will right click, edit. I have limits. I would say the minimum was 0.5 inches. Sorry, inches. Yeah, in here is going to be 0.7 inches. There you go. Let's see, animate. Oh no, it's not doing the thing. Okay, seems like I'm missing something. I will click. Oh, what? No, the session is about to expire. No, don't expire. We're in the middle of a tutorial. Okay, so I will drag this thing up and down. Ooh, seems like I need to use a different logic in here. Should be because of the orientation of the these things. Yeah. So okay, so let's see if I just with adding a minus and adding a minus sign in here, I get what I need. No way. It is having troubles. Okay, let's go. Edit. Okay, so seems like I cannot use. Should they be inverted? Of course. Okay, 0.5. There you go. Okay, perfect. It was just a problem from my side. Okay, so now it is simulating the movement. That's perfect. That's perfect. That's what we want. So it is under the limits. All right. Okay, perfect. So I will continue adding tutorials about these comparison things so you guys can judge which software do you like more. Actually, I find a lot of fun doing these videos. So I hope you have enjoyed. And if you like, please don't forget to subscribe and also leave the like. Thank you. Oh, by the way, you can continue this other video. It could potentially potentially the next video on this series, could be potentially another video tutorial that I have. Cheers.